make a note of my number on the screen for any technical difficulties during the webinar. Along with me is Shivkami Bharti in support, Dr. Yogesh Kumar Bhatt, Executive Vice President and Business Head of StackRoute, Dr. Vishnu Priya, Head of Products and Solutions StackRoute, and the presenters of today's webinar, Saurabh Gupta, Vijayananda, and Anirban G. Kindly keep your microphones on mute. Please keep sharing your questions on the chat window. We will take up the questions at the end of the presentation. Look forward to seeing active participation in poll questions as they pop up. Now I would want to welcome Dr. Yogesh Kumar Bhatt, a veteran in the field of education and research. He brings with him 22 years of experience in corporate training. He has many product launches to his credit in the areas of information technology, data science, and management. Thanks for joining us, Dr. Bhatt, to welcome our experts. Over to you.
Hi, good afternoon, everyone. Yogesh here. Anirudh, I see that there are many people walking in right now. I can see 5 people walked in last. So maybe we can just hold for another 1 minute. It looks like people increasing. So we just hold for another 1 minute and then we'll start. Hello. Okay, I think the number of people crossed 50, and we have waited for about a minute extra. So we can start. So for those who just came in, my name is, maybe you can just go back to the last slide for a second. Yeah, for those who just came in, my name is Yogesh Bhatt. Let me welcome all of you to this webinar. A very good afternoon to all of you. Let's move on to the next. Okay, so what I intend to do here is to introduce ourselves and introduce your speakers for you today before they get deep into the topics of the webinar. StackRoute is a venture of NIIT. StackRoute started as an incubated cell within NIIT in 2015. This year we'll be finishing 5 years of our birth. StackRoute started with a view to disrupt education and training in IT. As all of you know, NIIT has been in the front of IT education for decades. Idea of StackRoute was to come up with entirely new models of training, which we did over this time. There are a few milestones here. We started with a program which we very proudly call as StackRoute Immersive. That program is for full stack developers. Then we expanded into a remote offering, which is meant for working professionals. We expanded into the digital series for architects, engineer managers, and we came with something called StackRoute Full Stack Quotient, which is to judge where a full stack developer is in the journey of his maturity. We worked with very good brand names in between, and yeah, let's move on. So today, as we speak, we have an entire set of offerings. Can you move the slide, please? Which covers the entire stack, right from a fresh hire up to leadership. So for some reason, this slide is not moving. Whoever has the control, Anirban, can you move it to the next one? Yeah. So we do, as I mentioned, an immersive program for the fresh graduate hires. More recently, essentially as a response to the COVID-induced situation where a face-to-face program doesn't work, they come with a remote version of the same program which produces product engineers and software engineers. We have a stack of programs for developers, for architects, for product managers, for program managers, and for leaders. We cover entire gamut of the future skills in these programs, and we have very good offerings in the area of data science, AI, and ML. That's the kind of subject which we are going to talk about today in this webinar as well. What we do in data science is that we cover, again, the full stack, right from big data engineering, Hadoop, Spark, Scala, up to data lakes, Delta lakes, and we do programs which are, of course, technology agnostic, but we really specialize in doing, say, big data as well as machine learning on either Azure platform or in AWS platform. Further, we also customize our programs. Our belief is that a data science program is very successful, especially for working professionals, if it is customized to the specific domain. Like if we talk about the healthcare domain, and we'll have some talk on that today, we do programs right from clinical analytics to log analytics to stream analytics and to how the IoT system works in healthcare. Similarly, we do program in other domains as well. Yeah, let's move on. With those words, let me take this opportunity to welcome the speakers. We have a very good lineup of speakers for you today. Thanks a lot for all of them to join, and very, very warm welcome. Let me first introduce Saurabh Gupta, our first speaker. Saurabh is a technology leader. He is General Manager for Data Science and Analytics at Michelin Digital. He is also an author. Very recently, he has authored a book on Practical Enterprise Data Lakes Insights, which is published by Press Publishing. Earlier, also, he has authored various books and articles. He has worked with Packet to author one on Advanced Oracle PL SQL Developer Guide. And before that, an Oracle Advanced PL SQL Developer Professional Guide. He is a graduate from BITS Pilani and holds a management degree from Harvard Business School. Very warm welcome, Saurabh. Glad you could join us today. Let me also introduce next speaker. Next speaker, Anirban. He is a senior consultant with us here at StackRoute, specializes in AI and data science track. He has very vast experience in both in data science space as well as into teaching. He's a founder for a robotics edutech startup in Bengaluru. He is instrumental in a project which is a multi-billion dollar project for a UK utilities industry, driving the digital transformation program. They're using data lakes. He's an Azure data scientist, and specializes in machine learning and big data on Azure. So welcome, Anirban. Glad you could join us today. Then our next speaker and the last speaker for today is Vijayananda. Vijayananda is a fellow AI and data science at Philips Research. He leads a team of data scientists at Philips. He's working projects for the Philips internal business units as well as for external partners and customers. His focus is on machine learning and deep learning in the medical domain, especially in healthcare, related to numerical data, medical images, text, and waveforms. And again, he has several technical publications to his credit, and he's a well-known speaker at conferences. Welcome, Vijayananda, and welcome again to all of you. Before I hand it over to Saurabh, let me just give you a perspective of what to expect today. Saurabh will start with how do you develop a data strategy for an organization and how data lakes fit into that strategy. Now, he will obviously share his perspective from his experience, which is more specifically in manufacturing domain. Then on, it will be Anirban. Anirban will say how a strategy will get into execution straight away with a demonstration on how data sets, he demonstrated data sets to show how a data lake will provide reliability to data lakes. After Anirban, then we will have Vijay. Vijay will share his views from his long career in healthcare domain, and his focus will be even before you jump into data lake, are there certain preconditions? Are you prepared for that? Is it the right thing for you to do? And are you at the right level of maturity to really benefit from that? I think that covers it all, and it will be a great insight. I personally look forward to listening to all three speakers, and I'm sure all of us will benefit greatly by this vast experience we put together. With that, over to you, Saurabh. Over to you to start. Thank you. Thank you very much.
Thank you, Dr. Yogesh. All right, so good afternoon, everyone. I hope everyone is keeping safe and keeping healthy during this situation, and that gives us the opportunity to run through the webinars like this. Thanks, StackRoute, for inviting me to share my thoughts on data lakes and data strategy. So I'll take this opportunity to start with the proceedings of the webinar. The point that I want to cover in my section is the data strategy. So how do we build the data strategy and why it is important for the organizations who are undergoing the digital transformation, and even those who are matured, how do you balance the framework of defense versus offense approaches to exercise their data strategy in the organizations? Now, coming from the manufacturing domain, what I've observed that we have plethora of data, we have large volumes of data, and data is the new business. We actually want to exploit and explore more and more use cases out of the data. And in order to do that, it requires us to have a robust strategy and strike a proper balance, whether it is internal consumption or it is an external consumption. We need to understand that why this strategy is important and what are the roles and responsibilities that each of the teams share, and what are the objectives that we are going to achieve with the framework that I'm going to discuss in my section. In addition, I'm also going to discuss, I'll give a teaser around how to conceptualize the single source of truths in an organization, which predominantly we called data lake. How the market of data lake has matured over the time, and what are the opportunity size that will push us to understand the potential and go for the adoption and think of architecting data lake within our organization. Towards the end, I'm going to lay down the subject of the webinar, which is introduce the Delta Lakes. So I will sort of connect the current day challenges, or say the downsides of Data Lake, and how Delta Lake comes to the rescue and how it addresses the challenges that are associated with Data Lake. All right, with this, I'll come to my first slide here, which basically talks about the data strategy. So as I said, most of the industries in today's world, they are going on at a different pace and velocity towards digital transformation. And digital transformation is not just the function of cloudifying the systems and connecting them together and automating the business process, but as per the market study, data is gaining a new is a critical point in your digital strategy. Why it is important? Because once you start connecting the data, it is not just for the usage and consumption of the internal workforce, but unless until you exploit the data, it holds no meaning. So, and you are already incurring a lot of operational expenses to hold that data and to host those data systems. I'm going to talk about is a framework which is called defense versus offense. And being the practitioner of this framework for quite some time, I think it helps a lot in clarifying the primary objective of the data. Is it the data retention, and is it is the data the priority, or is the business objectives connected to the data is the priority? So what, in a nutshell, defense means is it helps in minimizing the downside risk. It helps in putting a safety net, or say a governance bench on top of the data that helps us understand that what should be the privacy control, what should be the access framework, how the security has to be addressed, and core in core, it helps us understand what we actually want to do with that data. And towards that reason, towards this cause, you might have seen the emergence of the new roles like chief data officers, and this role gets plugged into the digital officers and the world, and primarily the responsibility of the chief data office is to streamline the data management and build a robust strategy around the data staging and data consumption. The other thing is the data offense. Now, data offense is all to do the business objectives. How do you make value of this data that we have within the vicinity and within the peripheries of the security and privacy guidelines of an organization? And it may be different. It may be different for manufacturing. It may be different from BFSI. For retail, it could be much relaxed. And for healthcare and the medical industry, it's very, very strong. So how do we support the business objectives? How do we ensure the profitability of the data? How do we commercialize it? How do we monetize it? How do we build these models? How do we capture voice of customers and connect it to our internal sales functions and multiple functions that are responsible for overall customer experience? That is what is offense approach of the data. Now, we all understand that where do we draw the line? What is defense versus offense? But I've seen, based on my experience, very often we see the challenge that what should be the proper proportion of defense and offense in an enterprise data strategy? Where do we say that, okay, this much of, how do we balance between the control versus flexibility? Where do we draw the line of putting a net and opening it up for consumption? So this is the framework. How do we draw the how do we balance the equation is through the centralized data management and decentralized data consumption. So what centralized data management means is we have multiple source of truth. We have multiple data systems which are continuously generating data, but first of all, we need to put them onto a convergence point, which we call it as a data lake. It's not as simple as I speak, that you just connect all the data systems together and dump all the data into the data lake. Instead, there are a lot of challenges related to putting the control and addressing to the geographical norms of handling data, whether data can be hosted onto the cloud systems or not, and how do we control the different views of data, variance and velocity of the data. But in a nutshell, the point is that single source of truth is the strategy. But single source of truth doesn't mean that all data has to be dumped at single place. Instead, it can be business aligned. For example, manufacturing domain has got different business units. Everything is not manufacturing, but now with the diversified sort of models, business models coming into practice, we do have something which is entirely concentrated around manufacturing the products. Then we have around different revenue streams using this data. So these are the business alignment of the data organization, and that is what called the centralized data management, meaning the overall operational, the data operations gets to the centralized framework or centralized data team. Then we have the decentralized data consumption. Now, management is something that puts onto the control, and it's more on the defensive side, but decentralized data consumption is an offensive approach and basically opens up the data and empowers your internal workforce to connect data with their decisions, with their overall, with their day-to-day business routine, and then make some data informed decisions. All their decisions will be backed with the data and the analysis that they have done. What it requires is to open up the systems, open up the data for access, and give the appropriate data literacy education to all your business users, so that they can transform their role from existing or more business centric to a citizen data centric. Now this, and I can give you some case studies in this regard. Now what Airbnb, companies like Netflix, Viacom, what they did was, because they operate at a very low operational cost, but once they start opening up and their business goes onto the global mode, it's very difficult to route all their queries to one single central team of data scientists, which is a bunch of 10 engineers. What they did was they created a sort of a bench, which they call it as data university, and they opened up the data access. They defined and built personas, who needs what for data in what format. Somebody who is coming at the leadership level might just need end of the day a dashboard with key insights. Somebody coming as a data scientist need data distribution, has to be integrated. So they opened up the data, they educated their internal workforce, they evangelized the data tools which were meant to be for specialists. Now it is open for generalist. Now everybody on the business front face will feel comfortable using this data and generating insights and doing slice and dice of the data, and then be more informative when it comes to data. So that is called the democratization of data and analytics. And this supports the concept of how do we scale offensive data consumption, decentralized data consumption at scale. The other point that I wanted to bring up is what you see on the top right is the data strategy spectrum, which gives another perspective on how do we balance between the defense and the offensive approach of data strategy. Although I have listed down by industry, but believe me, it again comes down to the use case. If I have the business objectives defined, I can tweak around with the equation of defensive versus offensive. I can say that for all those business objectives which are related to, say, for example, master data management, or the data quality management, or data operations, all those will fall under defensive. And this is something the one that I just talked about is common across the industries, whether it is retail, whether it is BFSI or healthcare. Everyone has to take care of the data operations and master data management, and that's when we need to fall under the defensive spectrum. When we are going for a very like a product development organization, when we are developing analytical dashboards, when we are opening it for democratization objectives, then we need to be more offensive. We need to flex the safety nets, the security paradigms, and we need to ensure that we follow the access frameworks a very robust access framework, so that it goes through approval and then someone gets the access and then goes on, consumes the data and generates some meaningful insights. So we see this spectrum by industries, but it again comes down to the use case, what use case we are trying to achieve, how it is connected to our business objective, and that basically determines the adequate proportion of defense versus offense. All right, so on what you see on the bottom right is are the suggestible readings. So my last book was on the data lake. How do you architect data lake for management and for architects? It starts with the data acquisition strategy, moves on to data processing, clearly puts forward the differences between the older format of data management in an organization, what were the workarounds, what were the challenges, and how data lake addresses it. Then it also gives a primer on the high availability of data lakes, which is not so prominent, but it's a concept that we ideated with this book, and it's going to be coming in future. And then towards the end, it gives a primer on the data operations. So it provides end-to-end view, architect's view on how do you build data lakes within organization. And the concept of data democratization and the AI democratization that I just talked about is something that I sort of condensed my experience building strategies around this, and I published a article with Analytics India magazine. It's very recent one, and it lays down a 5-point strategy if you are thinking to democratize data science and AI in the organization. Basically starts with identifying, elevating the data literacy levels, identifying the data tools and evangelizing them, and then evangelizing the use of data. And then cultural changes are again quite critical, because this is sort of a disruptive innovation concept, and it tends to bring a change in the cultural shift, the way people think, the way people work. So how do you tackle with those challenges in organization? So I would suggest, if you want to go deep into the data strategy, how to architect data lakes, please go through these content, and I'm sure you'll find it useful. Anirudh, can we have the poll question, please? Okay, so I have a question here, which now just since I'm starting with the enterprise data lake, I want to understand what are the challenges that you guys have faced while building these enterprise data lake in your organizations. Is it lack of data strategy, technical challenges, cultural and organizational alignment challenges? If it is none of the above, or it's not applicable.
We'll be closing it in 5 seconds.
Okay, so I believe the primary beneficiaries of my first slide would be the people who fall in this 31% that we do not have that data strategy. And going by my experience, I think the defense versus offense approach, although it needs leadership buy-in and sponsorship from the executive leadership of the company, which are the chief digital officers and the chief data officers. But what I meant to say is that it drives the clarity between the objectives of exploit versus explore. Whether we are finding ourselves in the data exploration stage versus whether we are already ready for data exploitation. Okay, thanks Anirudh for running through with the poll question. Now the next section that I'm going to cover is how do you conceptualize data lake? Now, since we have established the concept of a single source of truth and multiple versions of truth, I would like to lay down the framework. How do you capture the single source of truth onto the single platform? And over the time, how many layers do you need to cross through like curation, discovery, transformation, and once it's ready for analytics consumption, that's where we start evangelizing our consumption layer for multiple versions of truth. In a nutshell, how it looks like is, if I talk in technical terms, the single source of truth is nothing but our data lake, and what you see in the bottom is the data ops, which takes care of the overall healthcare maintenance and the telemetry maintenance of your data lake. What you see in the extreme right is the multiple versions of this truth. Now, as the data lake cleans this truth and comes to a final refined version, which we call as a golden version of the data, then you create multiple versions of data. For example, a customer experience data set, I can have a different perspective and I can draw out different insights. That is my version of truth. And Anirban can come and say that, okay, this is a different version of truth. I can create new opportunities in this new geography. So these are two different multiple versions of truth from the same data set. How it gets integrated and how it gets consumed as an endpoint is what you see on the right. You create analytical products, you expose data APIs, you expose machine learning models as a service, and then you, of course, think towards commercializing and monetizing data sets. So that's the overall, a very high level view of conceptualizing data lake. Now, if I take a minute to go to cover these 4 blocks. Now, data acquisition deals with your how do you bring in the data from multiple source systems and stage them onto this platform. It can be batched versus stream. I'm going to cover that concept in my last slide. Then you have the insight, discovery, and development. That means all those data engineering community practitioners, they need to discover this data and they need to connect or stitch the business processes using this data handle. They need to start developing the business logic to make sure that, and that logic could be like enhancing the quality of the data or creating some curated data sets, which are very often used by the power users and the super users of the data. They can curate data sets which can be readily available for power user community. Then you have the optimization and governance. How do we make sure that data reconciliation is happening appropriately on the daily basis or on the frequency that the DevOps and the data ops teams have set? How do we make sure that this data lake is not getting converted into a data swamp, meaning we have the data which this platform is holding, but without any business accountability? How do we make sure that the data source systems are appropriately cataloged and the data governance council has the complete visibility on what data is getting in and what is the business value getting stamped on it when it goes on, when it approaches towards the right? The last one is the analytics consumption, and that's where we have, over the time, we have seen multiple consumption patterns coming in. You might remember the days of data warehouse where we just had the plain reporting, the OBI reporting, or say cross tabular reporting. Then we moved on to building the data products with ClickView, with Power BI, and with many other data visualization platforms, and those were majorly focusing around the descriptive or say augmented analytics of data. Then we sort of matured into a way where we said that this is going to be like a data science lab, and we will onboard the data scientist and equip them with the appropriate toolkits to work on this data and initiate some research initiatives. So these are different architectural patterns, and one of the patterns that I recently came across in my track was that this analytics consumption was entirely shielded from the rest of the layers. And if your data organization is aligned by the business, you would see multiple versions of data lake while there is one single consumption layer for entire organization. And that makes a lot of sense for somebody who is aggregating the data at a different level. For example, if one of my last company where we used to do the financial, where my team was doing the financial reporting, we were aggregating the data from multiple systems as in units, and these were all units working independently than each other, and that's where we had a common consumption layer. But common consumption layer used to fetch the data from different business layers, business data lakes. And that's how we created data products on top of the unified consumption layer. So that is another way of consuming the data. That's another way of architecting these data patterns. Now, now since we have talked about the strategy and what at a ground level it looks like, I would also present what the industry take on the data lake maturity and adoption looks like. So if I need to plot the maturity and evolution of data lakes between time and business value, so and then you can of course put a frame of defense versus offense on this graph, but in simple terms, what time versus business value would look like, that we start with the evaluation of our tech stack, our platform skills. So if you map this evaluation exercise across people, process, and technology frame, you would find yourself that where do you stand and what's the gap that you need to fill in X amount of time. That's the evaluation exercise. Then you start putting down you be reactive by aligning yourselves to the data objectives. You set up the IT processes, you set up the foundation of data operations, and you try to be efficient so that it becomes ready for consumption as soon as possible. The third stage, which comes later in the time and has got a maximum business value, is the proactive. And this is the phase where you try to reap out the benefits of the work that you have done in the last two stages. Proactively, you come up with the analytical products and you start thinking around the AI transformation. And this is all proactive. So nobody from the business will come and say that I'm going to sponsor this, but in fact, you start creating prototype to evangelize your capability, your platform, the technology, and showing the value that this is what it can bring on the table. Be proactive in that. The last stage, which is still very, long way to go, and it's still a very instrumental stage, is an enterprise. You achieve the ultimate nirvana with the data platform, and you say that now we say that this is the time we have end-to-end data-driven culture. Most of our business units and the analyst community is empowered with the data. They feel comfortable using the data, and for each and every small request, they do not bug around with the data product development teams, and they take the time and it goes on to a different scale altogether. So data-driven culture with the data platform, centralized strategy, and decentralized consumption is the ultimate enterprise level nirvana of this data strategy would be. And it takes time. Believe me, it takes time to mature and reach up to that stage. Very often we see the benefit story getting worked in at the reactive and the proactive stages. All right, so the market size of the data lake is growing at the rate of 20.6%. And by 2024, sorry, the entire data lake market is going to be $20 billion evaluation. And there are predictions from different analyst communities. Now, Gartner says that by 2022, 75% of all the databases will be will be deployed or migrated to a cloud platform. And these numbers are actually directing towards the trend that we are following in. That digital transformation cannot be done separately. Instead, it has to be aligned with your organizational data strategy. At the same time, how we are expending the benefits out of this data, how we're exploiting. So that will justify our efforts towards moving all these 75% of databases to the clouds. Now, I'll take a land on the data strategy and take off on the data acquisition strategy in a data lake. In a very simple terms, how the data acquisition strategy looks like, there could be two approaches. One is batched, the other way is streaming, which we frequently call as CDC, the change data capture. Now, batched way of ingesting the data is to pull incremental data from the source by firing a query and at a set frequency, seeing the changes and apply on the target systems. Very simple, no biggies in this. You have two systems, source and target. You fire a query from the source, take out the incremental data and apply on the target system. In case of streaming technique of acquiring the data and ingesting the data is not by firing the query, but reading through the transaction logs. Now, most of this, while architecting the data lake, your source systems which generate the data are mostly transactional in nature. If you start firing the queries on your transaction systems, it might hamper the performance. So in that case, we go and read the transactional logs, we extract the changes, and we start applying it. Now, the challenges with these approaches are, when you see the data lake from a high level, is that it's not closer to the transaction systems that we were used of. So there are challenges related to ACID transactions. You do not get the durability of the transactions. Then schema enforcement is a challenge. That means if there are schemas that you want to get rid of, or you want to stamp it out, you cannot do that with these data lakes. Partitioning and versioning is a challenge. If I have a data table or data set which has got a column which is multiple, which is a high cardinality column, so you end up creating small files, and it's very difficult to partition that data. So those are the challenges, and then you cannot take the snapshots of the data from the data lake. That's where, and these are the challenges that everyone lives through without realizing that, okay, and they develop their process assuming that these cannot be resolved. And there are workarounds to do that. But now what Spark did last year in 2019, they launched a project called Delta Lake, which intends to provide a storage layer and enable the ACID transactional compliance on the data. Okay, it's a beautiful concept that complies with the ACID properties of data set, brings it closer to the data systems in a very classical manner, and then it tries to get rid of the challenges that we just saw on the data lake. It supports the schema enforcement. You can take the data snapshots from the data lake. Now with this, I've set the context of where we were, enterprise data strategy. How do you exercise them is through the data lakes. And then who is the new baby in the zone is the Delta Lake. So with this, Anirudh, I would like to hand over to Anirban.
Hi, Anirudh. Can you share the access again, please?
Yes.
Can you confirm, Anirudh, if my screen is visible?
Yes, Anirban, it's visible.
So thank you, Saurabh, so much. That was really insightful. Thank you for joining, everybody, and good morning and good afternoon to all of you, depending from where you have joined in today. And I hope that all of you are doing safe and fine in this testing times. So my name is Anirban Ghatak, and let me just take a step back and quickly tell you what I'm going to do in the next 15 to 20 minutes. I'll be drawing up from where Saurabh left the webinar and move more into the technical aspects and the implementation aspects of this particular topic. I'll be starting with the big data timeline because this is a very wide forum. From the registration we have seen from top management, to consulting, to delivery, to development people. And then I'd be talking about the key differences between the Lambda and the Delta architecture. And then I'll have a couple of demos. Now, one demo is very straightforward, and the second demo is intermediate, but I would request, in case the folks in this webinar are not into development or coding, I would request them to hang on, because the examples would be very simple, and it would be interesting if you hang on with me on the demo part of it. And then obviously I'll be handling over with pleasure to Vijayananda to speak about the use cases on the healthcare segment. So let's get started. Now, just to make sure that everybody is on the same page, because this is quite a wide forum in this webinar. This is the big data timeline, which I want to quickly go through. And it all started with the major timelines on this slide, as you can see, with Hadoop coming in 2005 with their MapReduce algorithm and HDFS file system, and then a group of researchers at UC Berkeley putting up a research paper on RDD and saying that how in-memory computation can work faster than traditional Hadoop. The same group eventually created Databricks in 2013, and in the middle we had a data lake coming in. And if you follow the StackRoute YouTube handle, you'd see my last webinar in which I talked about an interesting insight how a blog, an internet blog in 2010 sort of started the concept and the term of data lake. And then we'll be talking into the topic, which is the Delta Lake. It's a literally cutting edge technology, because it's 1 year. Delta Lake was officially announced in April 2019 at the AI Spark Summit, and it's approximately 9 months to 1 year that the technical community has been using Delta Lake. So as you can see in the slide, our focus would be the last 3 blocks, in which I'll be talking about data lakes and Delta Lake, and I'd use Databricks for my demonstration. Now, as we go to the next poll question, and I would request Anirban to put in the poll question, and this poll would ask you about the biggest challenges you as an audience have in terms of creating your big data pipelines for your customers, and I'll give maybe 7-8 seconds for you to poll the answers. So as you can see, the results are here, and it's a unified division with a quarter of you saying and acknowledging that you're not involved in big data and would love to. That's perfectly fine, and that is the intention of this webinar. Another quarter, 25 to 28% are saying, performance issue, jobs taking 4 hours, 6 hours to learn, and business expects it 10-15 minutes. Complex code and API to get and update data due to a change request from business, that's another 14% each, and change of business logic at another 19%. So superb. So as you can see, the challenges are split into all those 5 options which has been shared. Now let's go back to our topic and to our slide, and let's try to see that what were we doing so far, and how Delta Lake and Delta architecture comes into play. Now we have something called as the Lambda architecture, and what it does is that as you can see, like the mathematical Lambda section, it has 2 streams, two pipelines to manage, one for the speed layer and for the batch layer. And this is what our friend Saurabh was also talking in the last part of his webinar section about stream data and batch data. And imagine a big data scenario which you have implemented for your customer, or you are implementing for your customers. Once you hand over the project to support, a lot of things can change. Example, your client may go for a merger and acquisition in Southeast Asia, so their business topology and the geography changes. There could be logic changes because there could be some mathematical formula, and those mathematical formula has changed. So you have to go back and incorporate those change and get that data back with the corrected mathematical fields. You could have a requirement changes because the strategic changes in operations might have changed. Your customer was previously buying certain products. Now they have decided to put a factory in Thailand and make those products. So you need to incorporate those changes now. Business process changes and localization changes. Perfect example is businesses in India going through GST norms, and you have to incorporate GST now. Version management, like who approved it? I did not approve it. Who approved this data to go into particular data lake? Audit logging, regulatory, GDPR comes into my mind when I talk about such compliances. And then you also had, you also needed a unified view to combine the speed layer and the batch layer. Example, using Azure Polybase to see a unified view of your of your streaming data and your batch data coming in. You might also be required to do your AI ML experiments and your models based on that particular view. Now the problem with this was, to maintain and take care of these updates and challenges, which I said it's a complex governance process. It is not that it did not work. It actually depended on case to case, and also the maturity of data in that particular organization, the architectural maturity, and how that architectural team actually implement this particular Lambda architecture. From a sponsor point of view, the business unit, the cost center that was paying money for such kind of initiative. Now, I had seen with my experience that this project eventually became an OPEX heavy kind of a project, because, there were a lot of change requests that were coming in, a lot of key resources like the architect, the business analyst, the senior big data engineer getting locked into the operational change request other than moving on with fresh data initiatives and projects in the organization. So now we have something which takes care of this paradigm with a unified layer, one after another, and this is the Delta architecture. And this is again just to match. This is what Saurabh was also referring in his part of the presentation. And if you look carefully, that you have your core data lake, which might be implemented in Amazon or Azure, or you can have your native HDFS, taking the data lake. And then you have the three layers, which is the bronze layer, the silver layer, and the gold layer. And the gold layer is the business ready and the business critical, the fine layer, which is ready for business and data scientists, data steward to use. And the bronze layer is the landing layer, where you ingest all the data. And as you move from left to right, as you move from the bronze to the gold layer, your data quality improves from left to right. So this architecture is what Delta architecture is all about. And if you implement Delta Lake, you will see that you will be implementing this very efficiently, and that is also the concept of my second demo. All right. Now, first, let's go to this first demo, and I also introduced my user persona, Asha. As you can see, this lady, a software engineer. The name is in support of humanity, and Asha means hope. And I'm hoping that we'll come out of this situation we all are in. And the first challenge that Asha is facing, imagine, 25% of you said that you have not used big data or data lake. And you want, after this webinar, you can go back and you want to implement something quick and dirty, something like a unit test to incorporate data lake first. How would you do it? So the first way you can easily do it is that you can create in Azure a Gen 2 data lake, and then use the connection string from the storage account, and you can connect it to a Databricks, which is running on a very simple DS3 V2 kind of an infrastructure, which is the frequently used cluster type, and you can have one master and two slaves running your data. So let's go through it. So I'll be just changing my screen. You might see a black screen for a second because I'm moving on to Azure. Okay, as you can see that I am inside Azure now, and I'm in the demo 1, and I'm connecting my data lake with Databricks. Remember that there is no direct component in Azure for data lake Gen 2. You have to create it through storage account. Since this is a webinar, I've already created a storage account, as you can see, and within the storage account I have created a container called as HR. And within this HR, I have this very simple flat file which has my name, my gender, and my department, which is analytics. As you can see, this is the CSV file, and I'll try to ingest this file into data lake. And how do I do it? As I said, I repeat, this is a unit testing demo. This is not for production use. So as a quick test, you can use the connection key, which is here, and you can move into your Databricks cluster. And as you can see, I am inside my Databricks cluster now. So as you can see, I'm inside my Databricks cluster, and my cluster is running here. And this is the cluster which I already talked in my PowerPoint, that it has a standard DS3 V2 cluster with one master and two slaves. And you can also see that the code for connecting it is quite easy. So all I have done is that, I have set up a connection string with my storage account name and my connection key, and then all I have done is I've given the path with the DB utils widget application, which is commonly used, and then I've just used a data frame spark.read.csv, which is commonly used, and just given the path of that particular storage account. And then if I just do a data frame.head, you can see that I see the return type of my name, my gender, and my department, which is analytics. Now this is definitely not for production use, but I wanted to show that how easy it is for a developer to get started into Data Lake Gen 2. Just as a note, if you plan to use such kind of connections, you have to use other secure things like service principal or use token in production kind of an environment. You can also consider connecting other sources. If I can just show you the data sources. You can also connect very easily other components like Blob, Cassandra, JDBC, Kafka, Redis, and this has an option to auto-populate your code. If you just click it, it will draw a code template, and all you have to do is change the credentials. All right. So so that was the first demo, and like I said, that the first demo is going to be very easy and simple, so that all of you can go and use it after this webinar. The second demo which I would be talking about is little bit more complex, in the sense that it talks about the key features, and again we have Asha coming in, and it talks about the key features of Delta Lake. Now the previous one was a data lake. Now imagine that Asha is working on a project now, and she's working with an IoT data set where she is ingesting stream data, and somehow we have the same problem, like the business logic is getting changed, the schema is getting changed, and how easy Delta Lake makes to handle all this kind of thing. So as I said, in Delta Lake, you have the bronze layer, which is the raw ingestion. You have the silver layer, which is the filtered data engineered layer, and the gold layer, which is meant for a data scientist, your data steward, and the business level aggregates. The most purest form of data, you hand it over for data science purpose. Now, how it works internally is that in this demo, I'll be creating a file system in my Databricks file system, because it's a webinar, and as you can see that I'll be creating it in the temp folder in my database file system. And as you can see that it creates three folder levels, which are the three levels: bronze, silver, and gold. And these are my bronze, silver, and gold actually created in my Azure Databricks file system. A bit how it works internally is that whenever a user performs an operations to modify something in the table, like insert, update, or delete, it is broken internally. Delta Lake breaks it up into actions, and these actions are then recorded in something called as a transaction log. As you can see, this particular part is a transaction log, and in this way it ensures that atomicity is preserved through commit. Now, whatever Saurabh was talking about, single source of truth, this is what enables single source of truth in Delta Lake, by the use of by the use of transaction log, and this is also the defense strategy which Saurabh was again talking about. So, and another thing to note that whenever there are 10 such commits made, 10 update or 10 inserts or a combination of certain activities from business due to production data moving in or due to a change request, every 10 commits creates a checkpoint file, and as you can see there is a checkpoint file here, and that gives you the data lineage. So example, if I have to find out which was the last version changed internally, the Delta Lake uses the checkpoint to quickly find out which was the last version changed. Optionally you can also partition the file. In my demo I'll be partitioning it on date, and this picture also from Databricks gives an example where the partition is done on date, and natively all the file on disks are stored on the PARQ file format. And then I'll be moving to this demo and help Asha to see how Asha can use this time machine, which is the versioning of the data, how ACID form is enforced, schema changes are enforced at a developer level, and you don't have to over-engineer these things, because Delta Lake gives you this 2-3 features already within the capabilities of Delta Lake. So I'll be moving again into Azure. So here I am. So the first thing I'm doing here is that trying to create the path of the 3 layers, which is bronze, silver, and gold. And as you can see, I've given the path, which is temporary StackRoute tutorial, and followed by the names. And if you go to data, you can actually go and see this has been created after you execute this block of code. Since this is a webinar, I've already run the code, and as you can see, if you go to this same folder, you can see that this things are already created in for me. All right. So I'll go again to the demo. So after I create and give the path in my temp folder, and it is not necessarily that you will give the path to Databricks file system, you can give it to your data lake also, or to your HDFS path also. What I'm doing is that I'm creating an IoT data set with date and device ID using some random numbers, and I'm also starting the partition on the date from 1st of January 2020, and this is the first path where I am ingesting all my data, which is the bronze path, as you can see. And then if I just load the data, you can see that I've loaded my bronze path where I'm ingesting all the streaming of the data that is coming with on and off state of a particular device, and with the device ID and the date on which I have captured it. So nothing fancy in it. Whatever data is coming, I'm just taking it inside into my bronze layer. I can also do a normal, data engineering stuff, like, I can do a count, and I can see that, I've kept 50,000 each on the on and off stage. Now, this is the first challenge which Asha faces. Now, Asha has done everything correctly, and now business has changed the logic and said to Asha that, Asha, you know what, you have to now capture under repair status also. Then all that Asha needs to do as a big data engineer is used to define this under repair as an action. So as you can see that the new field is incorporated in the action, and then Asha can, once it is declared, Asha can just restream that data back into the silver path, because internally it locates the checkpoint and appends the new stream in the silver path, as I was explaining. One good thing is that here is an option to see the streams coming in as it comes. I have stopped the stream, but if I run each cell one by one and come to this particular cell, this part will go green, and you can see the input data coming in and the output data going out, which means you can see your processing rate of the data coming in. And so it's a very good tool in terms of visualizing the data which is coming in. And then again, Asha does a count, and it says that, okay, now the repair count has come into my data set also. All right. Now, Then Asha finally takes this data because she has to move it to the gold layer, because that is where the data scientists, data steward, business owners will work depending on the governance which is set in. Asha again calls the checkpoint location and then gives the path of the gold path, and the data automatically moves now from silver to gold. And as you can see that within the same notebook, you are moving data from bronze to silver and silver to gold, and it is so neatly integrated. Now then, there could be another case where Asha mistakes an email and tries to add something using with a miscommunication, trying to say that adding another column which is an user ID. So if a developer is trying to add something by accident with the native coding structure, you get an error because there is a schema matching which is done, and if you just try to put anything, if you are not following the correct delta format and trying to use your traditional Spark programming to update it, there is an exception caught and it is not allowed. And if you have to make such schema changes, you have to use commands like merge schema, which is another addition which is given on the Delta Lake. Finally, there could be a case where a time traversal might be required, saying that I need to check the version of the data before this change request was implemented. How do I see it? So all Asha needs to do is call the delta log, which I explained in my PowerPoint slide, and it lists out what are all the commits that has been performed in the transaction log, and then depending on the version that Asha thinks she needs to pop in, and maybe here Asha thinks that she needs to call back the version 10th, because after 10th on 11th there was a change made and she needs to load 10. So she just gives the 10 in a variable called as version before schema change, and just loads it again from the silver path, and continues with her data engineering work by loading that old version of data. And that is what in the world of Delta Lake we call it as time travel. Okay, and finally, as you can see that even atomicity is enforced through ACID transaction, and whatever changes that Asha made, maybe using of the additional ID, which is user ID, she can enforce that atomicity and again take the updated data stream into the gold path, as you can see, and continue with her day job. So as you can see, these are the top 3 and 4 features. Obviously, this is not a all summary kind of a notebook, but I think it has given you certain advantages and certain aspects which you would appreciate, which Databricks is giving you on top of Data Lake. All right. So that's about my demo. I just move on to my slide now. Just bear with a minute. So I think my demo is done. I hopefully you saw some aspects like time machine, time traversal, ACID transaction, atomicity, schema changes, how it was handled by Asha, and how this concept of single source of truth is implemented at a cloud level, at a technology level, using Delta Lake over Databricks. Now I would be handing it over to our next esteemed speaker, Vijayananda, we'll be talking about insights of Data Lake and Data Lake from a healthcare domain. And I would request all of you to keep popping the Q&A questions so that all 3 of us can take. And over to you, Vijayananda.
Yeah. Can you hear me?
Yes, Vijay, we can hear you.
Okay. Thanks, Anirban. Yeah. So hello, everybody. Good afternoon. Good morning, as Anirban said, wherever you are. So to continue on this data lake, my focus is mostly on from the healthcare perspective, and what I would like to do is just give a very brief overview of the data lake, especially covering from the just a second, from the healthcare perspective. Now, before I dive into this, the details of this data lake, I would like to give a high-level understanding of, at least from Philip's side, where I'm currently working on, how we utilize these data lakes, because many of the, especially the machine learning algorithms that are built, require that kind of a huge amount of data over a longitudinal period of time, and this enables creation of the algorithms. And the data lake, if you just look at data lake in healthcare, I mean, even from a normal clinical side, it runs into petabytes of data. So there is a need to leverage the technology and manage this high volume collection of clinical data. And when I say just manage, it is not just collection, but curate and address the regulatory requirements of that as well. And just to make it clear, what I mean by the word data lake, or especially the word lake, is that if you understand a normal water lake, it's a large body of water, preferably probably in a natural state. But if you want to consume, you would take some water, you clean it, package it and bottle it, and then drink it. And many users can come and examine the water. They can dive and take some samples. Very similar to that is the data lake that I envisage, where it serves a lot of purpose. It serves a lot of, tries to answer a lot of research questions as well. Now, coming back to this slide, in especially the healthcare data lake, I see that there are two types of usages. So one is the primary use and the other one is the secondary use. Now, it depends on, let me give you an example of a primary use. Primary use is where the data is directly consumed by the clinicians, and it can be used for diagnostic purposes or for treatment recommendations. For example, let's say there is a cancer patient, and there is a lot of follow-up typically for a cancer patient. Then over a period of time, every time the patient visits, and the oncologist has to recommend what is the treatment pathway. We call it as a clinical pathway. Then we need to provide or enable the oncologist to look at the longitudinal data of the patient. Probably he might want to say find similar patients who have gone through a similar trajectory. Of course, when I say similar, it means which body part has this cancer, what is the staging level, what kind of measurements, the size of the tumor, and what kind of treatments were taken, in what sequence. For example, a similar patient might have taken a radiation therapy, chemotherapy, and then a surgery, or in a different sequence. So basically, we need to enable the oncologist or that particular fraternity to look at the longitudinal data. Now, this is what I mean by a primary purpose. A secondary use of the data would be to take the data and use it for research purposes, for developing, let's say, new insights, algorithms, correlations, etc., etc. Now, if I look at this particular slide, you can see in the left there are different purposes for which the data can be used, and also there are several entities in both primary as well as in the secondary use. For example, there is a concept called a controller, a processor, and the purpose for which the data is being collected and consumed determines what can be done on the data. What is the legal basis for collecting such a kind of a data is the key question that needs to be asked whenever there is a collection of healthcare data. And within the healthcare data, there can be several types of data, several IT systems are there. If you look at a big hospital, there is, of course, departments like radiology department, oncology department, and neuro department, and there are several systems within that. So each of the data in some will be collected in their own set of database, and so there is a need to see how these data can come together, process it in a way that it can be consumed in a nice way. Of course, in some cases, vendors do follow some kind of interoperable standards, but in some cases not. There is a standard need to be defined, and hence there is a need to get all of these different kind of data and create that kind of longitudinal data. And whenever it comes to secondary use, one of the key things that we need to keep in mind is the anonymization. That means we have to remove the patient details, demographics, so that anybody looking at the data after it is de-identified cannot re-identify the patient. So this is one key aspect that the difference between a primary and the secondary use of data. Now, if I look at the secondary usage, typically what happens is, if I look at the AI ecosystem, the first few steps do involve acquiring the data from various clinical systems, doing the de-identification I just now mentioned, and the ground truth creation. That means you need to do some kind of labeling and annotations, especially in case of supervised learning. And then, of course, the ML creation, the testing of the model, validating the model in a clinical perspective. And then, of course, you can share and then finally integrate that in the clinical workflow. So some of the key things I want to drive here is the fact that, as I mentioned about the de-identification, and then there is also consent that is quite important during this phase. So basically, consent involves getting the necessary approval and agreement from the person who owns the data. And typically, the patient is the owner of the data, and hence the consent is sought from the data subject or the patient. And consent. So the funny thing is that it's not just enough to ask for consent for processing the data. You need to consent. You need to get consent even for participating in a particular study. So especially if you're aware of the GDPR guidelines that came in force in Europe, and we also see to some extent in other countries as well. This getting consent is a very important task. So even before we talk about ingestion and keeping the data in a data lake repository, we need to take care of these kind of, I would say, preconditions. And data lake also holds not just the raw data that comes in, but also the annotated data, as I mentioned here, and the kind of cohort that gets created for the analysis purposes, and the cohort will also have both control data as well as the test data. And on the right hand side, you see that I have put some IDs like data ID, annotation ID. So what is important in case of healthcare data lake is the ability to identify uniquely a particular data. It could be as I said, raw data or annotation data or data used for validation. And the reason for keeping such a kind of information is at any point of time, we need to have mechanisms to repeat a particular test. So let's assume that I have created a fancy algorithm, machine learning algorithm to do auto segmentation of, let's say, a brain tumor of an MRI data. Now, if let's say I get the regulatory approval, then the FDA can at any point of time come and ask, can you repeat this particular measurements or the performance in terms of the sensitivities or dice coefficient that you have got. So at any point of time, we should be able to repeat that. That means I should be able to take a particular experiment that I did, and that experiment will be using some set of data. It will be using some environment of the training. It will be using some annotated data. So I should be able to repeat that experiment, which means I need to keep track of all of these different types of data that I have used in multiple of these experiments. Then I would like to address a bit on the exact problem statement to have a data lake. Of course, there are many, but I have chosen the 4 just to illustrate the importance of each of these. And the first one is about the data governance. So data governance involves having some kind of a mechanism where there is a decentralized, centralized data. Let me explain that particular term. First of all, let me be very clear that companies like Philips, they don't have access to the clinical data generated in the hospital, even though, for example, Philips does manufacture MRI, CT, etc. It doesn't mean that the data is owned by Philips. This is very similar to other healthcare companies as well. So there is a need to have access to that data. And as I said, a patient is the ultimate owner of the data. But in many cases, what happens is the data that we collect for this kind of analysis can be spread across different regions. For example, if you have data coming from a hospital in Germany or France, or let's say China, you can't just take the data out of that country and keep it in one centralized data lake. Although there are a lot of reasons why we would like to collect data from multiple regions, because if, let's say, we develop an algorithm, we would like to generalize the algorithm by having the training data taken from multiple locations. To give you an example, in mammography, to let's say identify the lesions, if you are creating a deep learning algorithm, the CT breast mammograms look different because the breast density is different in different regions. And if you have to really generalize that kind of an algorithm, you need to take the training data from multiple locations. But you're not allowed to get the data out of the region. So there is a need to have a decentralized system, but you should be able to learn from each of them. Of course, there are various mechanisms to do federated learning, etc. But the key thing here is the data lake is decentralized, but you have a mechanism to identify where that particular data is. The second problem is about the trust and security. So this is basically about how the data is being used, because you have an agreement with the patient or with the clinical site that this data will be used for some purpose. But what is the trust that you are going to give them that this is indeed being used for only that purpose and not for any other purpose? So there is some kind of transparency that is needed. Whenever you use the data, the other person who is the owner will also come to know about it, so that they build this kind of trust. And all of these kind of aspects or capabilities should be built in as part of the data lake. Consent I already mentioned about. And the ground truth, of course, ground truth is a separate, I would say, aspect for a machine learning, to build a machine learning algorithm. But the important thing is how do I manage this ground truth that can be associated with particular data? There can be many such labels that can be created for different purposes. Point number one. Point number two, we have to enable the clinicians in this particular case to create the ground truth in such a way that the data can be acquired from somewhere, but the ground truth or the ground truth creation from the clinician can happen elsewhere. So you should not be physically giving the data to them to do the ground truth creation, because, as I said, because of the data residency laws, but it should be possible that you can expose the data remotely and they can annotate it. And the last one is about the disparate data, which is more of how do I have this kind of longitudinal data over a period of time. And this is quite challenging, because I did mention that we need to de-identify when you put the data onto the data lake. But at the same time, over a period of time, you get the data from the same data subject and you need to stitch that data to an already de-identified data in the data lake. This is quite challenging because if you've already de-identified, you don't know to which patient or to which data subject this incoming data belongs to. If you really have to do a prospective study, so let's say that I'm doing a prospective study for a pregnant woman, in the sense I'm collecting the data in the first second trimesters to figure out whether I can predict a preterm birth for that woman. Now, if I'm collecting the data and I'm putting into the data lake, I need to know that I'm stitching the same data. But as I said, since you have de-identified, you need to have a mechanism where you can still stitch to the same new ID that you have put, but at the same time not be able to re-identify the patient back. So that's one of the key aspects of having the disparate data, longitudinal data. The disparate data is, as I mentioned here, the data can come from different types of devices, and the other key aspect here is the patient is actually roaming around. It is not that the patient goes to the same hospital every time, same diagnostic center every time. And if you have to really collect the data from these various data sources and stitch it, it's quite challenging. And of course, there are different approaches to handle this. These are some of the challenges, and I just wanted to talk a minute on this. How are we positioning the data lake from the healthcare perspective? Typically, what I've seen is that there is always this clinical zone where there are devices in the hospital, and there are certain standards, and then there is research zone on the top that I have shown. Now, since I'm talking on the secondary usage, this particular diagram clearly says that before the data leaves the clinical zone, you need to have the de-identification and the consent done. And once the data reaches the research zone, you could choose to do some kind of a processing, doing some kind of ETL, index it so that you can use the data for search purposes, and then allow the algorithm development. Now, this also means that you are invasive in a way that if you have to get the data, you need to put these software, these components into the clinical zone. The other way of doing is that you could directly, for example, send this data to the cloud if the clinical site allows. Of course, your cloud, your services on the cloud should be fully secure. But then that particular area where the data directly goes to the cloud is only owned by and maintained by the hospital. And from there, you could use the de-identification, consent, etc., to put it into another staging area and finally to the object storage, so that you avoid being invasive and putting extra software within the clinical site. So I'll stop here. So the intent of this talk, at least my talk, was not to talk about the detailed design, but of course there can be several design alternatives for the problem that I spoke. But the intent was to just talk about some of the challenges and what points to be considered when designing a data lake from the healthcare perspective, and what needs to be kept in mind, especially while coming up with a high-level architecture in terms of regulatory. How do I take care of regulatory, privacy, consent, etc., etc. Thank you. Over to you, Anirban.
Thank you, Vijay. Now we would be open to some questions. You can either type in the chat window or raise your hand. We will unmute you, and you can directly ask the questions to our experts.
Anirban here. I think we have a question on Hari Priyan Vijay Kumar on initial data load.
Yes. Yes.
So can you give me the access so that I can show him something?
Sure.
So Haripriyan, hi, thanks for joining on this and asking that question. And so to answer you, I just took the opportunity to give from an Azure perspective, and then other speakers can add, what are the ingestion options and how do we actually get data into data lake. Now, in Azure, you have two kind of ways to ingest data. One is bulk ingestion, and there you have multiple options. Example, as you can see in this official documentation of Azure, that if your sensor is sending a lot of data, like our demo with Asha and her IoT project, and then the native thing, you have the AZ copy tool, which copies everything. You can also have the Storage Explorer, and this is exactly what I did in demo one. And with Storage Explorer, I uploaded a file before the webinar, which had my name and other details. You can also create a pipeline using Azure Data Factory V2. Make sure you're using V2 because it's more powerful and updated than V1. Or you can also use, other Spark frameworks. One thing which is not mentioned here is that you can also connect another cloud. Maybe example, I talked about the merger and acquisition, and an acquisition in Southeast Asia might have AWS, and you can connect AWS S3 bucket also in here. You can also write your own .NET code and do programmatic ingestion without using any of these components. And if you have event stream coming in, you can use something like Apache Storm. So these are the various options, and it depends on the use cases. How do you want and when do you want to ingest the data, and also take care of your governance, that all data, you just don't copy and paste everything and put into your data lake. So there has to be some nomenclature of what data business wants to go into data lake. Anything to add from the other speaker, Saurabh and Vijayananda, on that particular question?
No,
I
nothing
think
from
Anirban, you covered it well. But I'll connect back to the last slide that I had in my section. Primarily on the principles, or from the principal standpoint, you can have, irrespective of the data structure, whether it's structured or unstructured, you can have batched or say streaming way of ingesting the data. Or third way is you write your custom logic to move the data from one system to another. And then there are commercial tools, there are open source tools available to support your data acquisition strategy. That's it.
Thank you. Any more questions? Raghavan sir, I've unmuted you. Okay. Any further questions from anyone? I can unmute you so you can just directly ask. Okay, just a second. Sharath, I'm just unmuting you. Yes, Sharath.
Yeah, can we talk something more on the data governance point of view, like actually, because there's a huge challenge which we are facing from the data governance point of view, like what areas that we are supposed to cover when it comes to the data lake, right? Actually, or are there any specifically inbuilt or external tools or inbuilt tools which we would definitely recommend them, right, whenever we want to do any kind of data governance?
Saurabh, would you like to start on the data governance part, and then I'll conclude maybe best practices on data governance?
Sure. So, Anirudh, can you tell me the name of the person who asked the question?
This Sharath.
Sharath. Okay. Hi, Sharath. So the question is around the data governance, and I think I'll not be touching upon the commercial tools that are available, because there are plenty of them, and each of them have got their own unique selling points. But from the standardization standpoint, or from the capability standpoint, the data governance is supposed to take care of end-to-end what data is getting in the data lake and the data operations, that which eventually means that how the data is getting refreshed from the source systems to your staging layer, and how it gets moved from one layer to the curation, then transformation and analytics. The third portion that data governance takes care of is, you might have heard of the DevOps, MLOps pipelines. So to support the operationalization, or in different terms, we call it as industrialization of these machine learning models, analytical recipes, code recipes, how the data governance takes care of the sanity check of these different code recipes and the developer artifacts that we have in the data lake. So you might end up having a Git repository, the versioning repository, and orchestration of different processes within the data lake ecosystem, not just about the data refresh or data capture, but over the time, how the data moves from one step to another. That again is part of the data governance. And before that, when you are designing or say building up the data lake from scratch, how do you catalog the data systems? And if you go a step further, how do you enable search on your data catalog so that anybody who is coming with a data steward hat, how he can get access to the objects that will potentially be part of this data lake? So data governance is a practice. It's not, it doesn't comes down to a tool. Tool could be an enabler, but it's very important that we set the thought process right when you are setting up the data governance council. That's my take on the data governance. And yeah, over to you, Anirban.
Yeah, before I speak, Vijayananda, do you want to add something on that question on data governance from your side?
Anirban, you can continue.
Okay, so thank you, Saurabh and Vijayananda. I think my personal take on data governance is that, first of all, data governance should be there from birth of the concept. So whenever an enterprise is deciding on investing in data lake, data governance should go hand in hand, because if you do not plan for data governance at a management level and a business unit level, and if you leave data governance for the IT and IS team to do it on technical merit, that is a sure recipe of failure. And if you read up articles which are available in public domain on data lake getting converted into data swarm, one of the primary reasons such articles in the open ecosystem internet, they say that data governance is responsible because they did not take data governance in account. Okay, so that is point number one. Point number two is that most of us in the enterprise would be implementing data lake over the cloud, and in certain cases there are also citations of pure metal kind of a data lake, especially in the organizational units or organizations which are into patent business, R&D. So they still want to keep it on the pure metal kind of a thing. So if you leave the pure metal, who host their own data kind of a setup aside, and if you just talk about cloud, your data governance should be at two levels. One is at your data level, like which data should go to whom. Example, if payroll data is coming, in no way in my demo, it should anybody who has access to the bronze layer. If it is payroll data, it will not go. Maybe I'll create a fourth layer in which such confidential data goes. Okay, and it will never touch the bronze layer. So this kind of decision at a data level and also at a cloud level, because when you are talking about data governance, you have also to talk about that should be in sync with Azure governance or AWS governance. So that is also one aspect which I see that sometimes project team misses out, that they have brilliantly drafted with the project manager and the business owner and the architect that, okay, this is going to be my data governance framework and this is a new project, should follow such protocols for moving in data into a data lake. But unfortunately, they do not map it to their cloud strategy, and then that does not tie up. Third point is that tools, obviously this is an open forum, so I'm not in a position to recommend any tool. And as Saurabh said, that it's more of a cultural shift, it's more of a management shift, and getting the business buy-in to go into data governance and then move into data governance as a fundamental framework and then the cloud aspect of it. However, if one tool which is a product in Azure, I see picking up speed and space with my customers is ADX, it's Azure Data Explorer. Per se, it is not a data governance tool, but it is a very fully managed SaaS solution, and it's a data analytics service, and it is useful for real-time analysis. It is called as ADX, Azure Data Explorer. So go ahead and have a look at it. Although, as I repeat, it's primarily not a tool for governance, but it can be used to check in and do some quick analysis over data that is coming. So do check out Azure Data Explorer. Yeah.
Thank you, Saurabh and Anirban. Any more questions? Okay, I don't see any further questions, so I will be proceeding. We have an upcoming webinar, which is on 9 to 5 of Industry 4.0, the 9 technologies which are transforming Industry 4.0, and the 5 actions to embrace. The link for the webinar is pasted in your chat. Feel free to please use the link to access it. Also, a feedback form will also be sharing with you. We look forward to your feedback, and we'll also be pasting the feedback form link in the chat window. Thanks a lot for your time. I'll be holding on for a few minutes till you can click on the registration and the feedback form. And I would also want to thank, please, Anirban.
Yeah, so thank you, Anirudh. And as people are putting their feedback and checking out the next webinar, I, on behalf of StackRoute, would thank you, Saurabh, for joining in. Your session was really insightful for all of us. I would also like to thank you, Vijayananda, for taking time out of your busy schedule and sharing your viewpoints on data lake and data lake over the healthcare domain. Thanks on behalf of StackRoute team to both of you. Thank you so much for joining this webinar.
Also, I would like to thank Anirban and the speakers and Dr. Yogesh and Vishnupriya ma'am for making the time. Thanks a lot, everyone.
Thanks, everyone.
Thank you. Bye-bye.
Thank you, Anirban.
Thanks, guys.
Thank you, Saurabh.